Hi.
Hi.
Exam 3 review. Let's get over with. So we have chapters 10 and 11, which together have 12 sections of material, but it's actually like 10 or 9 sections. So chapters 10 and 11, we're going to have 10 problems, some with parts, because let's face it, if you are doing this exam the right way, which is you write your name, then you put your pencil down, you look through the whole test, then you pick up the pencil, then you go through the whole test and do the divergence test for every problem, you should be able to knock out 2 or 3 off of the list. And then you go back and you say, oh, there was a geometric series on 3rd page, there was a geometric series on the 2nd page, right? If you are doing exams the right way, skipping around and answering things you should be able to answer half of the exam correctly in the first 15 to 20 minutes. And then have the rest of the exam to mess with the stuff like integral test, comparison tests, the annoying stuff that takes, or alternating, whether you have like 3 different things to do. Power series that take forever to write out. Right, so that's the idea for this. So 10 problems, some with parts. We are talking about 100 points again, and we are talking about 16% of your grade, highest stakes. So yeah, that's that. Now, the topics are sequences. And you know that the only test for sequences, convergence, and divergence is the limit test. And I asked you to put that on top of the sheet I gave you, so you can have that. So sequences, and you are looking at 2 types of problems. So converge or diverge, that's obviously with the limit test. Or write the sequence, or get AN if the sequence is given. Remember when I gave you the sequence and you were breaking your head in class to figure out what it compresses into? So yeah, that good stuff.
That's the hardest thing so far.
To compress them in the...
As the homeworks go, if they just give you a bunch of numbers, like finding right how to compress it, that's like the hardest thing.
Then you have the 10 tests. 10 tests, which is the sheet. Memorize this so you can quickly plow through it. You know that the comparison tests work pretty much the same way. The root and ratio work the same way. Geometric has that R to the N. P series have N to the P. So opposite from geometric. Integral test, you can integrate. So there are very simple ways to see which test is to be used. Again, I say simple because, right, I have over 15 years of experience staring at this stuff. But for you guys, now that you have 15 days of experience staring at this stuff, but you do have 14 days from this point on till the exam, right? Your exam is on December, whatever Saturday is. December 6th, December 8th, December something. So you do have time. So sequences, and then 10 tests, and then you have power series, you have Taylor series, you have interval and radius of convergence, and you have, I spelled it with C's, calc of power series. That's it. I mean, when you take a look at this, I could have actually just said power series, no, just Taylor series and stuff, and you're done. So, this is one of those exams where we unfortunately don't have any word problems. So, it's just straight up calculations and things that you guys learned before. So, yeah. I'm sorry to disappoint. I can make it up on the final. I put like 4 or 5 word problems on the final if you're upset that there are no word problems now. No? Okay. So your 10 tests obviously converge, diverge, and then you have absolute conditional convergence to worry about when you're talking about alternating series. It's important to write those sentences at the end. It's important to state the test every time. So if you just write converge, diverge, if you hit it right, it's just 2 out of 10 points or 2 out of 8 points or something like that, right? If you just write converge, diverge, the more information you put, if there is work and it's logically everything sound, then you go up to 8 out of 8 or 10 out of 10 and so on. So make sure you write it. Now, some things that on the side wreck your exams are these things, so watch out. Shifting the counter. Shifting the counter, and that is your geometric series must start at 0 for a r to the n. If you don't have a 0 under the thing, you guys are not going to have a correct sum. So make sure you know shifting the counter so you can deal with that. That's number 1. Number 2 is the power series centered. At some value, because it's not the same to have a power series and power series centered at 2. So you have to make sure, and I didn't make a deal out of it for integration when I told you, if you have the integral, you just do general terms, but if you have the integral from 3 to 3.1, you have to center your power series at 3, otherwise it's going to be garbage. So that's another one that destroys your. And what was there? Was another one that it's. I mean, all other stuff. Don't assume anything. Retire common sense. Oh, sine k and cosine k that are added to AK can be ignored. So if you remember, we had that like n plus sine n. Yeah, n is going to take values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then sine n is just always going to be between -1 and +1. It does not contribute to convergence or divergence. You can just delete it. Much different if it's multiplied, because if it's multiplied, it can create an alternating. And when you create alternating, it could change divergence into conditional convergence. So you have to be very careful. So sines and cosines added to can be ignored, but if you have a cosine n pi multiplying the an or ak, then that cosine n pi is -1 to the n, and that's alternation, and that can potentially change a divergent problem into a conditionally convergent problem. So you have to be careful there. And that's all I have to say about the exam. So standard, 90 minutes, kind of 80, 85-ish minutes. No graphing calculators as always. You can bring the standard calculators or scientific calculators. And that's that. Bathroom before, bring some sugar. And if that big, bring a lot of sugar, I'll eat it. And that's it. Cool? Now, are there any questions that I could solve before we leave?
Yes.
Yes! Bring it on.
Okay, so I get like really confused when it's asking, like on MATLAB, when it's asking to like find the value of the series. Like I'm just confused about like when it's AN or when it's A over 1 minus R, or like 1 minus R to the N. Like
well, when they ask, well, if they're looking for the sum, then you are using the formula for the sum. If they're looking for a term, then you are computing the term. So if you talk about geometric series, for instance, 0 to infinity, AR to the N, the summation formula is A over 1 minus R. So now I can ask part A, find the fourth term in the sequence, or B, find the sum. So, right, what is that asking? Now, if you are looking for the fourth term in the sequence, well, the fourth term is when n is equal to 3, because the first term is when n is equal to 0, second term is when n is equal to 1, third term is when n is equal to 2, and the fourth term is when n is equal to 3. So to answer part A, plug in n equals 3 into AR to the n. No sum necessary because they are looking for individual term. And then you just compute AR to the n because A and R are given to you, and then your n is 3, so you will be able to compute that term. And then to answer part B, you run the formula. Run the formula A over 1 minus R to get the sum. Now, obviously, like we said it previously, here it is in blood. Make sure sum starts at 0, because if it's not starting at 0, then you are not going to have correct answers because the formulas don't work in that case. So sum must start at 0, and then if you want any kind of term, you just put n minus 1. So if you want a 127th term, you just put 126 there. You are looking for either the value of the term, which is A1 or A10 or something, or you are looking for the sum, which is when you use the formula. Does this make sense?
Yes. The only other thing is, like, when do you, like, what's the difference between when it's like 1 minus R to the N over 1 minus R, and when you want to use that
formula, we'll just use this one. It's much easier and faster.
So don't worry about the other one? Oh, cool. Okay.
Cool. Anything else?
How do you pick your BN for your comparisons?
You are always looking into, so what I say, you delete the fluff, right? You delete the fluff, and then whatever is there is what you are going to use for your comparison P series. So let's take a look at the fluff. So if I have a problem that says summation 2n squared plus 3 divided by 4n squared plus n minus sine n, like this, we understand that the largest degrees are n squared and n squared, and we already said earlier that sign, added or subtracted sign, because it's bounded by 1, doesn't contribute to anything. We can get rid of the fluff. And, actually, sorry, I wanted n cubed in the bottom. N cubed in the bottom. Over here. Because if these are the same, then the limit is 1/2, and because the limit is 1/2, it diverges by divergence test. So that kills the problem instantly. So if I have summation that goes to infinity, you can start at 1 or whatever, 7. When I say delete the fluff, then I just mean kill the 3, kill the plus n, kill the sign, and this problem looks like it's just 2n squared over 4n cubed, and that simplifies into n over 2n. No, 1 over 2n. There we go. And that's how you pick your bn.
Okay.
So kill all of the fluff.
And then you do the comparison.
Comparison, whether it's direct comparison or the limit comparison. Generally it's limit, but can be the other one too. And remember that I said comparison tests are the last resort tests. So if nothing else fits, if nothing else works, then you run comparison test and you finish it. So that's why on the sheet they are listed the last, right? So you went through the whole thing, right? We learned those in 10.5. We learned them like midway. After those comparison tests, we still had root ratio and alternating, right? But I like the sheet, the way it lays out, because first test is the most, it's the fastest and the quickest and the easiest test to use, which is divergence test, which is why you should try it against all 10 problems with parts. And then you will try to recognize geometric series and telescoping series and all of the other ones, alternating with the -1. And then eventually when you're done with all of that stuff, there's going to be a problem, and you will probably say, well, this has to be a comparison because everything else was there, right? But killing the fluff is what reveals your P series. Anything else? Yes?
Could you do a problem that like uses alternating series?
Of course. That's what I do.
Thank you.
Now, which one?
I don't really know, like anything.
Any.
I don't know like a lot about alternating series.
No, because you said, can I do it? It's like, yes, and just walk away. It's like when you ask someone, do you know what time it is? Yep. And just walk. Just walk away, and that's it. All right, so for whatever reason, this version of the book doesn't have a, so I have to. When you see a 1 and a 2 that are other, those are actually left and right parentheses. This is what I have. I mean, I
How do you do problems like that?
no, they're just parentheses.
Yeah. How do you?
I'm not sure what is the issue. What's the problem?
Yeah, no, it's just like why would you ever write it like that? Like how does that?
I think it's some issue with the compiler.
Yeah.
Yeah. So, but I've seen this problem so many times that I just know. So, which one should we do? Pick a number.
24.
24 it is. Oh, nice one. KLNK. Oh, you picked the perfect one. Summation -1 to the n ln squared n from 2 to infinity. I better be 2. Yep, 2. Good. Awesome. So first of all, we know it's alternating series because we see this -1 to the n, which is the term that will alternate the sign. So we're good there. The next order of business is for us to show that an, which is given as 1 over n ln squared n, has the two properties. Limit of an, it needs to be equal to 0, and we know it is because you have 1 divided by infinity. The second thing that we need to show is that it's decreasing, and we know that as well because denominator grows. Because as the denominator grows, the whole fraction is getting smaller, right? 1/2 is bigger than 1/3, but 2 is smaller than 3, right? So there's that part. Now, because these two are true, you are on a convergence branch. Now you have to check summation of 1 over n ln squared n from 2 to infinity. Now this is integral test. Use integral test. And when you use integral test, you have the, use integral test, and you have the three rules. First, is it decreasing? We said yes already because the denominator grows. Is it positive? Yes, because n is larger than 0 and ln squared n is larger than 0. So everything is larger than 0. So decreasing positive is the continuous. And that's also yes, because combinations of continuous functions are continuous. So now we can do the integral 2 to infinity of 1 over x ln squared x dx, which gives us improper integral limit. X goes to b, no, b goes to infinity of the integral 2 to b of 1 over x ln squared x dx. To integrate this, we use basic u sub, u equals ln x, du equals 1 over x dx, which is awesome because that's exactly what we need. So now I have the limit, b goes to infinity, and I have the integral 2 to b, and I have to plug in here du over u squared, because the ln is replaced by u, but ln is squared, so that's u squared in the denominator. 1 over x dx becomes du. So now when you integrate this, limit b goes to infinity, integral of -2 is -1, so this is going to be -1 over u from 0, so from 2 to b. And that gives us the limit b goes to infinity of -1 over b plus 1/2. Now the limit of this will give us 0 over here, and you just get 1/2, which means that the integral converges, therefore the series converges. And now you have your answer for the alternating. Since all three conditions hold and integral of 1 over x ln squared x, you can put the x on top, converges, the series summation 2 to infinity 0 n ln squared n converges by alternating series test. Now, it's actually absolutely convergent. So you can put AC actually, absolutely convergent. So if you're trying to remember what the rule was for this, it was you have summation of, let's go blue. You have summation to infinity of -1 n an. So that was the setup. And then you take an and you check decrease and you check limit an equals 0 as n goes to infinity. That can pass or fail. If it passes, you are on a convergence branch. You will take the summation an, and you are ignoring -1 to the n in this case, and that one can converge or diverge. If it converges, like it did in our problem, we get what we call absolute convergence, and if it diverges, we have a conditional convergence. And then if it fails, we just have over here divergence, because generally how you diverge. So it's like a tree. You never use -1 to the n. You just use the rest of the sequence, and then you look at for those two. If those fail, it's divergent. If they pass, you go down the convergence branch. You take the summation of an, so technically just deleting this term, and that one can converge, diverge. That's what our integral test kicked in when we were doing this. All right. So first I did the two proofs, and that's what brought us to convergence branch. And once on a convergence branch, you have to find the sum. And that's any of the 9 tests, right? You have comparisons, you have root ratio, you have divergence test, you have, right, all of these tests available to you. The one that we happen to use here was integral test. Cool.
So like it's integral test, or like I can.
Any of the 9 tests goes here. So I'll write it in blood. That's not blood. Use any of the tests to solve this. Now, when I say any of the tests, obviously, and I said 9, and you know there are 10, well, this is alternating series, so this is alternating series test. You already took off the alternation, so it can't be alternating. It can't be any of the other 9 tests. The only one it can't be is alternating, right? Because we killed it here. So, woohoo. All right. Anything else?
So that's almost asking if it's conditional or absolute, if you find it at first.
If these two conditions pass, your alternating series is convergent. Now, what type of convergent, right? And if you go back to the lecture, you will find me talking about the alternating harmonic. There you go, alternating harmonic. There. Cool. Anything else? Yeah.
With the integral test, I don't remember exactly how it was worded, but it was saying that
You do the 3 proofs.
Oh, I'm sorry?
You do the 3 proofs, then you do the integral, and then if the integral diverges, problem diverges, if the integral converges, problem converges. They do not converge to the same value. That's another thing.
Okay.
So you remember how I solved over here and I got that value of the integral is a half?
Right.
Your summation does not converge to a half. The sum is not half. Be very careful.
Okay.
The only 2 tests which calculate the sum are, which 2 tests? Telescoping and geometry. That's it.
Okay.
And it says in that square on the side, right, that you can find the sum for those.
Oh, okay.
Yes. Anything else?
Are there going to be any telescoping problems on that? There weren't any on homework.
I don't know why this book is weird. Telescoping is just fine. You have a telescoping, and then you have the partial fraction decomposition that can lead you into telescoping. Right? It would be a perfect question for the final. Right? You do partial fraction decomposition, and then boom, telescoping. And you can have a parallel problem with the same thing for the integral test. So there's that. Anything else? Oh, you forgot to charge it?
Oh, I just have one more quick question.
Yes.
So when you're saying that with the counter that it has to start at 0.
Yes.
Like there was this one problem. Like I feel like it was really easy. I just didn't. Like it wasn't clicking. So okay. It was just this one -0.15 to the k, but so like would it just be like to the j minus 2 or j plus 2?
Oh.
Sure.
I promise I will.
Okay, thank you. That's like my life.
For another 3 weeks. And then you're probably gonna burn it in some kind of ritual.
No, I keep all my books. In case I have any questions in the future, I can just go through my old stuff. Thank you. Thank you.
You're welcome. Let's see. First thing that I see here is the possibility to split this with a -1. So I'm going to start by saying that this is -1 to the k times 15 over 100 to the k, because 0.15, right? We can do as 15 over 100. And simplify this one more time. -1 to the k, divide by 5, get 3 over 20 to the k. So this would be the simplest form to write this problem in.
Can you just do like divergence test? Right off the bat?
It would fail, right? Because 3 over 20 is less than. If it was 20 over 3, it would kill it. The divergence test is inconclusive because the limit is 0.
Well, I mean, like right off the bat, before you do anything, it's -0.15 to the k.
It's 0.15. So the limit will be 0. It's less than 1. Anytime for something exponential to the k is going to be less than 1. Now, what kind of test is this? Alternating, right? Alt. It's alternating test because you have -1 to the k. So your AK is equal to 3 over 20 raised to the k. And now you ask yourself, is it decreasing? And the answer is yes. Is it limit 0? The answer is yes. Limit 3 over 20k equal to 0, answer is yes. So we hopped on a convergence branch. And since we're on a convergence branch, we'll do the sum of 3 over 20 to the k. And the sum of 3 over 20 to the k is going to give us convergence, because r, which is 3 over 20, is less than 1, and we have convergence. So absolute convergence for the alt series test. Now, you don't get to do the summation here because you can't. This is not the geometric series problem. So you can't add the terms to see what it converges to because it has a negative. Now, if this problem was just 0.15 to the k without a negative, we would be able to run the sum and calculate the sum. There?
Perfect, thank you.
Would you still have to write out all that you did in the sentence afterwards?
Yes.
Or you can just say it's absolutely.
You just write everything out. This is the more you write in these cases, the better. That bottle is so bothering me over there. It's been there for like 3 years. You can. Let's try.
Never actually seen it up there.
Yeah, you can only see it. You can see it from where I sit. I see it every time. It's like I can see it. Falling thing about the green.
What are some good ways to figure out to condense the stuff?
Oh, you have to memorize those sequences I gave you day one.
Yeah.
You need to know the sequence for 2n, for 3n, for n squared, for n cubed, right? To memorize a couple of numbers.
Like some of the ones in the homework, it would give you a list of numbers. I don't have the problem in front of me, but like one of them, you would end up having to condense it to like 5 times 3 to the n minus 1 over 2 times 3 to the n.
Yeah.
And like, how are you supposed? If you're given a list of numbers and this is what it condenses to, like, how do you see that? You know what I mean?
You
Just
have
trial and error, a bunch of different
yes,
textures. And like,
yes. However,
it's crazy.
for that time, right? You see that every for that particular one you wrote there, I can immediately tell you how, because what you have there is you have a 5 on top that it's factored. That means that every number that you had in the numerator ended either in a 0 or a 5. That means you can pull 5 out. Every number by what you wrote there is even in the denominator. You can pull 2 out. And here's your 5 halves. Now the rest in the bottom, what is the rest in the bottom? We just have 3 to the n, which means that sequence is 1, 3, 9, 27, 81. So once you pull that 2 out, you will be left with the basis. This is how it's, this is why it's so easy.
See, like, if you can pull a 2 out of stuff, or
Yes, if all of the numbers are even, 2 pulls out.
okay.
If you still end up with the even ones, that means you gotta pull out 4. So then you pull another 2 out. 2 times 2 is 4, right?
Okay.
If they're all divisible by 3, because adding digits you can spot that they all divisible by 3. If they all end in 0, pull out 10. If they all end in 5s and zeros, going through, then pull out 5. So you have to factor from each number as far as you can, and then the bear. Or harder to see is when it's plus minus 1, or So
That actually does help a lot, just being able to factor.
Oh yeah. But if you have, let's say, this is what you get used to over time. Like 2 to the n, when you start with 0 is 1, 2, 4, 8, 16, 32, and they keep doubling every time. But on the problem, right, you could be given 2, 3, 5, 9, 17, 33. Well, that means that it's 2n plus 1, right? Because it's this, and then each one of these is added 1. So those are a little bit harder to spot. And it's not 2 to the n plus 1, it's 2n plus 1. So that's a little bit harder. Which is something you had in the numerator up there. Those are puzzles.
They are. But it's like, there's no, I don't know. I was doing trial and error, trying like a million different things, and I was like, on a test, like if I'm given one of these and it's hard, this could literally just eat up 45 minutes me sitting here trying to figure out.
Which is why that's something you want to leave to the end.
Yeah.
But now you know that what you're supposed to do, right?
Yeah.
You are supposed to pull out everything you can, and then if you still don't have a basic sequence, you are going to say, what do I fix it if I add 1 to everything, or add 2 to everything, or subtract 1, or subtract 2? It's not going to be, 2 to the n minus 7/5, everything to the n squared, right? I understand that what you wrote might look complicated right now, but I am still going to call it a joke comparison to what's there in DFQ. Because you have to do that with power series, combining them into an answer that it's like a sine and cosine of the function. So condensing numbers obviously is the first step. All right. Anything else?
Are you ever going to give one that...
Let me chop you right there, yes. I don't know on this test, but in general, yes. Or I have in the past.
Okay, then I'll rephrase it. How do you do the integral test if it's not continuous?
What do you mean it's not continuous? All of them are continuous because you are transferring n's into x's, so you do have continuous functions.
Okay.
They're all continuous, right?
Okay.
So your integral will not contain n. There is something crazy that you learn in graduate school called the vague integration, which is integrating at the point, but no, we're not doing any of that stuff.
Okay. Cool. I have one more question, and then we're done. It's like an example because like I'm just confused on how to solve it.
I love it.
It's that. I mean, if it's not going to be on the test, then don't worry about
No,
it.
this is definitely something that is cool to put on.
It looks like they're asking for a sum, and you went for partial sums. We're not going to use partial sums, but it's cool to actually find the sum of this, I think.
I don't even know what I was doing, so that's...
We're not doing any partial sums.
Not a partial sums, but we're going to have a full sum for geometric. You have to have at least one of them.
Just a nice problem like 5 over k squared. Give the first 4 partial sums. Here's some points.
That's what the
You know
That's
what
what the divergence test is for.
Not
The easy points.
Throw anything in like that. All right.
I mean, I can avoid the problems with divergence test too.
No.
At that point, it's like, no. All right, guys. What we see here are 2 geometric series, and we have to do them separately. The biggest issue of this is that the counter is at 1. So we have to shift the counter. So currently what you have is that k equals 1, and that's no bueno, so you will subtract 1 on both sides. That will create k minus 1 equals 0, and you can rename it into an n. So that creates a substitution that k minus 1 is n, from where k is n plus 1. So this is a transformation that you have to pull off, and as the numbers change, it changes accordingly, right? So you can start your k at 7, and then you will be subtracting 7 on both sides. You will have k minus 7 and all of that. And then eventually k equals n plus 7. So, yeah. So now summation will start n equals to 0, go to infinity, and then you have your 3/5. But now you have your 1/4 raised to the k, which is n plus 1, plus 2/3, 1/4, n plus 1. So now we have summation n goes to 0 to infinity, and this is where you have to peel off an extra plus 1. So you have your 3/5 and then times 1/4, and then you have your 1/4 raised to the n. Plus 2/3, you peel off 1/4, and you still have your 1/4 raised to the n. Okay, so now you can combine this into a single sum by adding the constants in front, by factoring out 1/4. So we could have done that earlier, but it's okay. So what do I have? I have this 3 over 20 plus, when this cancels down, it's going to be 1 over 6 times 1/4 to the n. And now your series starts at 0 and it's raised to the single n, so we're good to go. As soon as I work out this common denominator here, common denominator is, I need a 3. Oh, don't tell me 60 is the lowest. Yeah, 60 is the lowest. Such is life. 60. So that's going to be 33, right? I don't like it. Oh, because 6 and... I put this by 3. Okay. And then we have 1/4 to the n. So now we're looking at the series n goes to infinity, 11 over 20 divided by 3, right? And then 1/4 to the n.
Isn't it just 19 over 60?
What happened?
19 over 60.
Is it 19, not 33? Why is it 19?
3 over 20 times 3 over 3, and then 1 over 6 times 10 over 10.
No, I was right, probably. Because you need to multiply this side by 3, so you have a 9 on top. And this side you need to multiply by 10, which is 19. I was just testing you all. Checking if you're paying attention. So that's 19 over 60 for A, 1 minus 1/4 on the bottom, which is 19 over 60 times, this is 3/4, so it's 4/3 over here. These guys would cancel, you get the 15, so 19 over 45, I hope, for the sum. Now, 1/4 and 1/4 don't have to match when you have separate problem like this, and then you won't be able to pull them together into a single one and mess up the fractions like I did. But you would split them into two sums, find the sum for one separately, sum for the other separately, and then add those two numbers at the end. If any one of those two diverge, the whole problem diverges, because you know how it is. You just need one PC to mess up the party. Anything else? Going once. Going. Looks like Desi is looking for a problem, so I'm just gonna.
I'm just going through. I'm gonna find something. Let's see, finish first.
Well, it's not fair because I only count 3. You have to look through like 200 pages, so. So I'm gonna stop the countdown.
Anything else, they'll just like send me Discord or something.
All right.
Oh, are you ever in your office on Fridays?
No. I'm not on campus on Fridays and Sundays.
That's probably why I've never seen you there on Friday.
Yeah. That's why.
I teach at Study Hall
Uh,
at Florida for student athletes on Fridays, and I always check